Alright, so our warm-up on 10.6, we're using the quadratic formula. If I were you, I would write the quadratic formula on your note card. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So in order to use this, we need our equation in the form ax squared plus bx plus c equal to 0 or equal to y. So we have these two on the same side, but we need to move this 5x over to the other side. So those will eliminate. And write your x squareds first. We have 6x squared plus 5x minus 6. Now we know a is 6, b is 5, and c is a negative 6. So let's plug in what we know into our quadratic formula. We have x equals a negative b, and b is 5, plus or minus the square root of b squared, or 5 squared, minus 4 times a times c. A is 6, and c is a negative 6, all over 2 times a, and a is 6. So if we simplify this, we have negative 5 plus or minus the square root of 5 squared. Well, 5 times 5 is 25. Then we have negative times a positive times a negative. I know two negatives are going to make a positive. So I have 6 times 4 is 24. And 24 times 6, you can plug it in your calculator. I'm going to multiply it out here. 6 times 4 is 24. 6 times 2 is 12. 14. You get 144. All over 6 times 2, which is 12. So then, simplifying again, we have negative 5 plus or minus the square root. If we add 144 plus 25, we get 169, all over 12. Now, if I were you, I would plug the square root of 169 into our calculator to see if it equals a nice number or not. So we're going to type in the square root of 169, and we get 13. So we really have negative 5 plus or minus 13 over 12. So we have our two answers, one with a positive and one with a negative. Negative 5 plus 13 over 12, and negative 5 minus 13 over 12. Let's solve both. So negative 5 plus 13 is 8. 8 divided by 12 is 0.6 repeating. And the other one, we have negative 5 minus 13. Oops, typed that in wrong. Negative 5 minus 13 is negative 18. Divided by 12, we get negative 1.5. So I know I did that a little bit quickly, but all we did was simplify our quadratic formula that we have up here and follow our order of operations: exponents, then multiplying, then adding and subtracting. So those would be our two places where this graph would cross the x-axis. A couple other quick questions for your review. From 10.1, this was graphing y equals ax squared, or comparing your graph to y equals x squared. So this is where we made xy tables, and we had to graph on our coordinate plane. So x squared, if we graph that, if you plug in 0, 0 squared is 0. If you plug in a 1, 1 squared is 1. And if I plug in a 2, 2 squared is 4, in for x. Same thing would happen on the other side if I plugged in a negative 1, because negative 1 times negative 1 is a positive 1. And this would be our parabola. So if you were given the equation to graph y equals 3x squared, we would make our xy table and plug in these numbers for x. So if I plug in a 0, we would have 0 squared, which is 0, times 3, which is still 0. Then we would plug in a 1. If I plug in a 1, order of operations tells me to do my exponent first. So 1 squared is 1. 1 times 3 is 3. Same thing if it was a negative 1. Negative 1 times negative 1 is a positive 1. 1 times 3 is 3. And then plugging in a 2. Exponent first, 2 squared is 4. 4 times 3 is 12. Same thing with the negative. So we would graph these as well. 0, 0, 1, 3. And I can't fit 12 on here. The couple things we would need to compare. 4 things. 1, 2, 3, 4. I would write these on your note cards. These are the things you need to compare. Which way does your graph open? Does it open up or does it open down? Meaning our arms are pointing up or our arms are pointing down. Then, what is our axis of symmetry? Where does your graph fold in half? This one is on the x-axis when x is at 0. Then, next, we need to determine, is our graph a stretch or a shrink? A stretch is when a out front is greater than 1. So if a here was like 2 or 3 or 4 or 8.5 or whatever number you want, if a is less than 1, for example, like 2/3, 1/4, 0.7, that would be a shrink, meaning your graph would be shorter and wider. So this one here, it was multiplied by 3, so this one was a stretch. And then last, our vertex. Is it a maximum or a minimum, and where is it? Of my green graph here, my vertex is at 0, 0, and that is the lowest point of the graph, so it is a minimum. So it could be a minimum or it could be a maximum if that was the highest point of the graph. So that was everything from 10.1. Then 10.2, we had to do same thing, graphing, but first we needed to find our axis of symmetry, which the equation for that, x equals negative b over 2a. So on our graph, we might have the equation, let's say we have y equals negative 2x squared plus 3x minus 6. So if that's our equation, we would need to find our axis of symmetry first. Where's our graph going to fold in half? So note A, B, and C go in this order. Because I just made this up, I'm not sure if it'll end up to be a nice number. So we'd have opposite of B. If B is negative, those two negatives would make a positive, but this time it's positive. And then 2 times A, and A is a negative 2. And we'd have negative 3 over negative 4, which would make a positive 3/4. Normally when we solve these, we're going to get a nice number like 2. Let's pretend it's 2. So our axis of symmetry is at 2. That's where our graph would fold in half. Then you'd have to plug 2 back into your equation for x, because you know that's what x is equal to find y. That point, once you find x and plug it back in, x and y, let's pretend we plug it back in and we get y as negative 1. That would be our vertex right there. And then our last point that we need to plot is 0, c, and c is negative 6. This means if I was to plug in x is 0, this times 3, 0 times 3 is 0, this times 0 is still 0, so all we'd be left with is negative 6. So that's a point we can plot. Well, how far away is that from our axis of symmetry? It's 2 squares away. So we can go 2 on the other side and draw our graph. There are 2 questions at the end of your test that ask you to do the same thing as 10.2, but then on 10.3, we asked how many solutions are there. Another way of saying that is solve. Where does it cross the x-axis? Or how many times? This one does not cross the x-axis at all, so this one would be no solution. If you get a graph and it crosses the x-axis 2 times, like let's say your graph looks like this, then you could write that there are 2 solutions. And if you get a graph where it's only crossing one time, like maybe your graph looks like this, it's touching the x-axis one time, there's only one solution. So quick review of 10.2 and 10.3. The steps we took. First, using your equation, make sure it's equal to 0 or equal to y. So for example, if you have 2x squared minus 5 equals 1x, make sure you move that x over to the other side so it's equal to 0. Then find your axis of symmetry. Negative b over 2a, and that's your dashed line. Once you find your axis of symmetry, that's your x. That answer goes in for x. Then plug it back in to find y. So plugging it back into your original equation from up here, so we would have like 2x squared minus 1x minus 5 equal to 0. We'd plug that number in for x here and here to find y equal to 0 or equal to y, same thing. And then we have x and y, we can plot that point. Let's say it's right there. And then step 3 would be to graph or plot the point 0, c on our y-axis. So if this one's at -5 down here, and then you're going to have to reflect that point over to the other side of our axis of symmetry. There's our graph. And if this was one where it said solve, you would need to tell me how many times does it cross the x-axis. This one crosses the x-axis 1, 2 times. So there would be 2 solutions. Good luck on your test. If you have any questions, please let me know.